So hey everyone, in today's class I'm going to discuss why we use Lagrangian more frequently in higher order or to dealing the question of classical mechanics. Basically, you know the Lagrangian is based on the classical mechanics. So why we use Lagrangian instead of using the Newtonian mechanics, the simple F equal to ma, because when we look at the Lagrangian and when we look at the Newton formula, the Newtonian formula looks very easy for us, but the problem in Newton's formula is that the first problem when I use F equal to m into a, or either I can use it in another way. Okay, so what we get here, we need to find out all the forces. What is F is the summation of all the forces we need to find out here. But in Lagrange, actually the main idea is that whenever we have a complex conjugated function or a very difficult situation, then why we prefer Lagrange, not this Newtonian equation. The reason behind that is very simple, because in Lagrange we require the energy. See, if I want to write the Lagrangian of a system is basically L is equal to T minus V. What is T? T is your kinetic energy and the potential energy. But if you see it, it have no physical meaning, because if I write Hamiltonian, again there is a Hamiltonian is T plus V. Yeah, it is a total energy, you know this. Physically it have a meaning, but when I use the Lagrangian have no physical meaning at all. So why we prefer Lagrange when we are doing the complex questions in physics? The reason behind that, simply I told you, because we are using the concept of energy here. Let's say we are just finding the Lagrangian for a system. We have a spring. This spring is just doing the oscillation with a displacement of x. Then the potential energy you can write half kx square. Okay, you can write down the potential energy half kx square, and the kinetic energy in this case is half m x dot square. So from here, if find the Lagrangian is T minus V, so it comes out to be half m x dot square minus x square. This is the Lagrangian of the particular system. We don't have any kind of bother about the Lagrangian. Okay, then if I use Euler's Lagrange equation, so according to this, if I do this concept, dl by dt by dq dot is equal to dl by dq. Q is, you know, position, and q dot is your velocity. So differentiate the kinetic energy term here, and so what we get this term 2m x dot is equal to, if you differentiate this, you get 2kx. From this side you get mkx, obviously half kx to x. Here is a what we can do, we can write it right down. We not take the common out here. We get half mx dot square minus half kx square. This is the way. So from here, what we getting actually, if I look at this, what I getting, this kind of function we getting here. So if we need to solve it, okay, then we say 2m x double dot is equal to k into x, okay, minus we have to use 2kx. So 2 cancel out, to x dot is equal to minus k upon m into x, and this is simply the acceleration of the particle, the acceleration of the system. But the same thing, nothing, this is m into a, you can say f m into a is equal to minus kx. This can be do by the help of Newtonian physics easily. Why we choose that complex mathematical conjugations, why we use this Lagrangian approach here? The reason behind that is very simple. Whenever the question become complicated, whenever the question become more and more complicated, it's easier to do the question by the help of Lagrangian. And whenever you have a more than one coordinate, then the question is very easy to deal with the Lagrangian, and the question you cannot deal with the help of Newtonian physics. You can do this, but it will make you lots of difficult calculation. So Lagrangian have no physical meaning at all, but in mathematics it have a great physical significance. By the help of this we can find out the total forces that acting on the particle. Also, okay, we can find out the displacement, the energies of the particle. So that's why we use the Lagrangian. Like say we have a double pendulum. In case of double pendulum, whenever we do the question by the help in a double pendulum case, we always use Lagrangian. We cannot do this question by the help of Newtonian mechanics, because this kind of question is complicated by doing Newtonian mechanics. So Hamiltonian and Lagrangian in advanced form is very important for us to dealing the question of classical mechanics. So I hope you understood why we prefer Lagrangian than the Newtonian physics.